record. Okay, you don't need this, you need this. Okay, so where we left off the other day was talking about short circuit evaluation. Short circuit evaluation is a way that Java and quite a few other programming languages basically let you not evaluate an entire sequence of Boolean expressions if it's unnecessary. So, for example, if you have a string of OR, if you have a string of logical ORs, as soon as you find a positive one, as soon as you find a true, you know that the entire set of ORs is all going to be true, so you don't need to resolve the subsequent ones. And that lets you code things faster. So that's where we left off. Now, next thing, order of operations. Okay, the short version of all this is you can't do logical tests until the values involved are resolved. So if you have true and false, you can't figure out the and until you figure out that one side is true and one side is false. So you have to resolve the Boolean expressions before you resolve your logical operators. Arithmetic expressions have to be resolved before equality testing or comparisons. So before you can resolve a Boolean, you have to have resolved any math that underlies it. For example, if you have a comparison, x is less than 3, well, you don't know if that's going to resolve to true or false until you know what x is and you do the comparison. Okay, so you got to do the math before you do equality testing or other comparisons. You have to resolve the individual Boolean expressions before you can apply ands and ors. So this is our whole big sequence. Parentheses first, arithmetic expressions second, right? We do the math first, then any comparisons, then ands and ors, and as always, same precedence operations are resolved left to right. So, for example, go to Paint here. All these late people. All right. For example, if we had the expression, int x equals 3, int y equals 2, leading to the comparison, Boolean b equals x is less than y, or what? Or x is less than 4 and x times x is less than y times y times y. Okay, what do we do first? Well, do the stuff in parentheses first. So one at a time, right? If there were some math here, which there isn't, I guess that was a failing on my part. If there was some math first, we'd do that. But here we resolve this. Is x less than y? Well, 3 is less than 2. No, so false. Okay. Up here, x is less than 4, so 3 is less than 4. That's true. And then this, x times x, 9 is less than 8. Well, that is false. Okay, so we've resolved the math here, such as it is, and let's figure out what the Boolean evaluates to. So then we have b equals false or true and false. Okay, so because these are same level of precedence, right? They're all Boolean Boolean operators. We resolve them left to right. So false or true. We do that first. Damn it. And of course, false or true resolves to true, because one of them is true. And then the next layer outward, get away. The next layer outward, true and false. Well, true and false is going to resolve to false. Okay, so in the end, b equals false. But that's how you do it. You do the math first, any comparisons, any relational operators, and then your logical operators like ands and ors. Okay, questions on that? We're all good? Nothing blinking in the chat window? We're all good. Okay. So, going forward. Backwards. So, Now we get into our if statements, our true conditional statements. So if statements get used when something happens if a condition is true, nothing happens otherwise. So here we're saying there's an if statement and there's not an else statement. We'll get to else statements on the next slide. So statements for executing the true case contained in a block enclosed by braces. We have a quirk in Java and in JavaScript and quite a few other languages where if there's only a single statement, you don't need the braces. So the basic syntax is if some Boolean condition is true, then execute this statement, right? If Boolean, we have a block of statements, so if this is true, we execute this block of statements. In either case, if the Boolean is false, we just skip over it. So in this case, we skip over the statement. In this case, we skip over these two statements. Okay, so I'm going to fire up Eclipse here, and we'll do a quick demo. Okay, so let's just do a fun with comparisons. Make our new, sorry, a little chaotic there. Fun with comparisons. Okay, so we'll give it a scanner object, java.util.scanner. And then we'll throw in the comparison stuff. Okay, so what we're going to do here, give our thing a new scanner object. So okay, new scanner object. And then we're going to ask for a couple of inputs. So okay, we'll say int x equals scanner.nextInt. Whoop. I guess I got to make that static. Okay, then we'll do the same thing with y. Okay. And then we'll call an evaluate method. So static void evaluate. Okay. Oh, int x. Okay. We'll call it int value 1 and int value 2. Okay, great. So with this, I'm going to do some logical tests, right? So first I'll see if they're equal, see if x is greater than, see if y is greater than, that sort of thing. Okay. So first test, system.out.println x equals y plus, right? Value 1 equals value 2. Doesn't like us doing that. Likes that. Okay. One of the weird things, these Boolean operators, see, the reason why we got an error there, I'll point that in case you weren't paying attention. Okay. Remember, these relational operators get computed last. They get processed last. So if I have this is a string, that's fine. I add it to value 1, that's fine. But I take this, then here I have a string, and I'm trying to see if it's equal to a number. So Java looks at that and says, oh, that's messed up. Strings can't equal numbers. This is a typing error, right? A type error. So it says incompatible operand type string and int. Basically, you can't do an equality test to see if a string is equal to a primitive. So I got to put this stuff in parentheses. Then this comparison gets computed first. It's going to see, is this true or false? Well, whatever that is, that's going to get appended onto this string as the word true or false. Okay, we'll do a couple more. We'll do x less than y and x greater than y. Okay, so easy. And there we have it. In fact, I'm going to embed this in an infinite loop eventually, but we'll leave it there for now. So suppose I run what's x? I don't know, x can be 32. What can y be? Let's say y is 64. Boom. Does x equal y? No, of course not. 32 is not 64. Is x less than y? Yes. Is x greater than y? False, right? It isn't. So in all these cases, right, we're doing a very simple thing like this. We're doing this test. However, we can embed this in an if statement. So this is what we're doing. Let's do the same kind of thing in an if statement. We'll do if value 1 is less than value 2. Okay. System.out.println x is less than y. Okay. We do another if for the equality. Value 1 equals value 2. System.out.println x double equals y. X is equal to y. And likewise, value 1 greater than value 2, round out the set, system.out.println x, x is greater than y. Okay, so in all these cases, only one of these is going to be true. X either has to be equal to y, less than, or greater than. And then I'm going to print out a string of things here, and then for whichever one of these is true, it'll display that. So here's where I'm going to embed it in the infinite loop. So I'll do while true. Okay, let's shift all that over. Okay, great. So as long as this is true, we're going to keep repeating this. So infinite loop. Okay, ask me x, and I will say, I don't know, 10. Ask me y, I'll do 10 again. Are they equal? Yes. Oh, why is it giving greater than? That's strange. I must have messed something up there. That can't be right. Okay, and it says x equals y. Let's stop this, because clearly something has gone off the rails.
I think you put greater than or equal.
Yeah. Yep. There you go. Okay. So that's fine. I mean, I knew it had to be something simple. This isn't a terribly complicated program. So there we go. So true, false, false, as we expect. And we get our printout, x is equal to y. Try again. Let's make x 10,000. Y can be 6. Are they equal? No. Is x less? No. Is x greater? Yes. And we have this. X is greater. Okay. So that's the basic mechanics. So remember, with an if statement, if the condition is true, you execute the statements. Otherwise, you skip the statements. Okay, so in the case where the x and y were equal, I printed out x was equal. I didn't do anything for the other two cases. Okay, we can do the same thing with an if-else, which I'll get to in just a moment. Okay, if-elses. So if-else statements get used when different things happen depending on whether the condition is true or false. So if the condition is true, there's an if block that executes. If the condition is false, there's an else block that executes. Okay, and as before, if you have a single statement block, you can omit the enclosing braces. Now, the else statement is always linked to the immediately preceding if statement. So basically, whenever you have an else, you have to have an if. An else statement can't exist independently of an if, because the else only happens if the if statement's condition is false. I'll do a quick example here. So with an if else statement, okay, if the condition is true, you execute the if statements. Otherwise, you execute the else statements. So you're always going to do one or the other. Okay, if we wanted to do the same kind of thing, we could do a simple one here. If value equals, value 1 equals value 2. Okay, else okay, so that's this. I'm going to do a couple. Where's my backslash? Let's make them not equal. Okay, so our ifs, by going through that block, we indicate that x is less than y, right? 6 was less than 7. And our if else's, we indicate that they are not equal. Okay, I'll put in another, this character afterwards. This backslash n, by the way, that creates a blank line of text in your console, so it's useful for that. Okay, so clearly this else is linked with this if, right? So I do this test. If the test is true, I execute this statement. If the test is false, I execute this statement. Okay, I'm going to do a second one with if else's. Again, okay, so for this one, I'm going to break it up into two things first. I'm going to do first if value 1 is less than, right, it equals value 2. I guess I'll do it that way. Okay, system.out.println x equals y. Then I have the other case, else, okay, and I'll make a block here for it. If value 1 is less than value 2, system.out.println x is less than y, else system.out.println x is greater than y. Okay, so simple thing here again. I have the if statement. If this condition is true, I go on to the else block. Within this else block, I have a standalone if-else pair, right? So if this condition is true, if value 1 is less than value 2, I print out x is less than y. Otherwise, I print out x is greater than y, right? Because I know they're not equal. If x isn't less than y, it has to be greater than. Okay, so this else, of course, is linked with this if. These are a pair. So I'm saying if this, right, we can understand this. Likewise, this if else is a pair. They are connected to each other. So even if I had a block of text here, right, even if I had like a block of something in here, this else would still be connected to this if. Okay. That's something people often have a little bit of trouble with. Okay, so I'll do one more, 7, 8. Okay, in both cases, yeah. Okay. Okay, questions on any of that? So that's our basic intro to ifs and elses. How is everybody? Anything in the chat there? We're all good? Everybody fine? Questions? I mean, ifs and elses are pretty simple if you get the rest of it. Okay. Now again, this is a simpler thing, right? So again, here we have If x is greater than or equal to 0, print out non-negative, else print out negative, right? So if x is at least 0, it's non-negative. I have a similar thing here. If x is at least 0, I'm going to by default say this string is positive. If x is 0, I'm going to set s to hold the text 0 and then print out s. Otherwise, print out negative, right? So in both cases, these are going to do the same thing, right? They're going to check whether the number is negative, positive. Here, the if-else is very simple. Clearly, this else is left with this if. But in this case, this else belongs to this if, right? Belongs to the else with if x is at least 0. This if is a standalone if. It's not affiliated with this else. Okay, people sometimes have a little bit of trouble with that. They think, oh, this else belongs to this one because this one is right before it. No, it's, you know, if you think that this is a block of, if picture this being a block of emptiness, then clearly this else has to be linked to this if. The else is going to be connected to this if regardless of what's in this block. Okay. Now, you can nest if statements. I did that already, but we'll mention it again. So an if statement is a binary test, right? It's either this or that. There's only two options. It branches just in two ways. So to cover more than two outcomes, you need to have nested if statements. So here I have some pseudocode describing my question about whether I'm going to walk or drive to where I'm going and whether I'm taking an umbrella or not. Okay, so first thing, question of whether to drive or not. So I check, is the distance greater than the walking range? So let's say, I don't know, walking range is like 2 miles. That's the upper bound of sensible walking range. Well, if the distance is greater than 2 miles, I'm not walking, I'm taking the car. So the next thing, decide which car to take. So if it's not raining, if precipitation is 0, then take the convertible, because why not? Otherwise, take the SUV, which has a roof. Okay. Now, the else here, this else is clearly linked to the first if, right? To whether distance is greater than walking range. Well, if distance is not greater than walking range, I'm not going to drive, I'm going to walk. So then the question is, if it's raining, right, I bring an umbrella. But if precipitation is 0, then leave the umbrella at home. Otherwise, bring the umbrella, and then I walk to wherever I'm going. Okay, so in this case, we had one if-else that can cover two cases, whether the distance is walkable or not. And then within each one of those if blocks, we had another split. So we had 2 base cases and then 2 more. So yeah, 4 cases we covered. All right. So I'm going to defer switch statements till Friday, but today we're going to do some practice problems. We're going to have some fun with conditional statements, and we're going to do practice problems, and the winner will get a fabulous trip to Hawaii, all expenses paid, something like that. So let's go ahead and do this. Okay, this is kind of like a lab exercise. If you want to, if you have Eclipse open, you can go ahead and type it in, and if you don't, that's okay. You can just try on paper or in Notepad or something. I'm going to zoom in. So first one, write a method that accepts 2 parameter strings named s and t and returns the length of the shortest one as a byte. If either string is null, the method should return -1 again as a byte. Okay, so if you want to do the null test, it should look like this, right? So if, say I have the string as s equals null is all you have to do for that. Okay, so go ahead, take a minute, and then if somebody has the, somebody gets it, well, they can yell out, hey, I got it. Otherwise, in a couple minutes, I'll show the solution. All right, well, if anybody wants to volunteer for doing this, you can unmute yourself and walk me through the solution. All right, do it one more 1 minute countdown and we'll see. There we go. We may have no takers. I should pause the recording, huh? Why don't I do that? All right, well, let's go through the solution then. So what should the method header be? We're writing a method. What should the method header be? Well, we got to give it a name ourselves. The question doesn't specify a name. What's the return type? Well, the return type should be a byte, right? It says, did somebody say there? Hey, look at that. People are paying attention. Yeah, it should be a byte. There you go. Okay, so let's do it. The method return type is a byte. Let's call our method Q1 because I don't have a better idea. And it takes two parameter strings S and T. Okay, so it should be string S and string T. Okay, and returns the length of the shortest one as a byte. So we can say, first of all, if either string is null, the method returns -1. So if S equals null or T equals null, return -1. Reason is, if we try to read an attribute of a null object, right, we can't test for the length before we test whether it's null, because then if we do this, if we do the we do this first, if S dot length is less than T dot length, return S. If either S or T is null, then this is going to crash. This is going to create an error. So else return T dot length. We have to convert it to a byte. Same thing here. So first we got to check whether the strings are null. And if they aren't null, then we compare them. So if S is shorter than T, we return the length of S as a byte. Otherwise, we return the length of T as a byte. Questions on that? Okay, moving on. Next one. So there it is. We do the null test and blah, blah, blah. Here's the solution. I'll post this up on Blackboard later. Okay, easy one. Write a method that accepts two parameter ints named X and Y, returns the greater one as an int. Very similar to the previous problem. Pause the recording for a moment. Back again. Here we are recording again. Okay, in this case, we're going to return either of the numbers as an int. So our return type will be int. We'll call our method Q2 and it accepts two parameter ints named X and Y. So int X, comma, int Y. And there we have it. How do we return the greater one? Well, we do a comparison, right? So we do if X is less than Y, return X. We do else, return Y. Now, in this case, if X is less than Y, we need to return the greater one actually. If X is greater than Y, we return X. If X isn't greater than Y, either Y is less than X, in which case we should return, if X is less than Y, then Y is greater than X, we should return Y. If they're both equal, it doesn't matter which one we return, so it might as well be Y, right? But if you're super paranoid about this, you could do something like else if X is less than Y, return Y, right? Because Y is greater, else return Y. So if one is greater than the other, or the other one is greater than the first, or in the case that they're equal, it doesn't matter which one we return because they're equal, but you got to pick one. So fine, return Y. Okay, either of those would be fine. All right, so here's the solution. There it is. Ta-da. Okay, questions on that? All right, next one. So write a method that accepts two int parameters named X and Y, returns true if either is negative, false otherwise. Okay, so if X or Y is negative, we return true. Otherwise, we return false. Pause the record. Okay, back again. So for this one, right, what are we going to return? We're going to return a Boolean. We're returning either true or false. So Boolean, okay, we'll call this one Q3, accepts two int parameters. So int X, int Y. Returns true if either one is negative. So if X is less than 0 or Y is less than 0, return false, or sorry, return true, else return false. But there's actually a much quicker way to do this. I mean, it's not that much quicker because you still got to do this, but we can actually compress it into a shorter expression. So if you wanted to save space, and you should always want to save space, you could have done it like this: int X, int Y. Just simply do return X is less than 0 or Y is less than, or Y is less than 0. Okay? In the case where either number is less than 0, it's going to return true. In the case where neither number is less than 0, it's going to return false. Excuse me. Okay. Questions on this? So this will work. This is valid code. It's not especially elegant. This one is a little better in that way, right? Because it avoids this unnecessary work. It's more compact. Compactness is good as long as it does the work. Questions on this? Nothing? You're all still there, right? Okay. All right. I believe this next one is the last one then. So there it is. I called it has negative and just did return with that. Okay, last one here. Write a method that accepts a char and a string as parameters, returns true if the string starts with the char, false otherwise. Okay, excuse me. Let's do this. Okay, so returns true or false, so therefore it must return a Boolean. Okay, method's name may as well be Q4. Accepts a char, so char C, string S, those are the parameters. Okay, we want to check if the string starts with the character. Okay, so if we want to check that, how would we check if the first character of the string is equal to the character parameter? How would we check that? What method could we use? Well, if you said char at, then that was correct. Okay, it's the char at method. So what we could do, again, return s dot char at 0, right? The first index equals C. Very simple, right? If the first character of S is the same as the character C, then that's going to be true. Otherwise, it's going to be false. Okay, so, or you could do this. You could also do the starts with if you want to check the string. So that's an alternate one, but you know, this is the most direct one because we get the character and there it is. Okay, questions on any of these? Anything? Nothing? Okay. So now that we've done a little bit of fun with ifs, we can bounce over to Coding Bat. Let's check out some of that stuff. Oh, I got a lot of windows open, huh? How about that? Okay. So we'll go to Coding Bat. Ah, damn it. I got this new security stuff. You guys are killing me. All right. It's probably not secure. I go to Google. There we go, coding that. Yeah, security stuff's a hassle. Okay, it must not be secure. What, you bastard? How are you not there? Urgh. Really? This semester is what they kill it for me? That's weird. All right, well, I guess that homepage no longer exists. That's the problem. That's strange. Okay, so we're going to do some basic logic problems. Okay, we'll do a few of these. So logic 1, basic Boolean puzzles, if, else's, ands and ors, that sort of stuff. Okay, so let's come up with a simple one. Let's do, I don't know. Anybody want to pick one? Nobody wants to pick one? Ooh, somebody's picking something. Okay, what we got? Makes sense. Last digit. Okay, great. Last digit. Where is the last digit? I'll find it. Last digit. There we go. All right, last digit. Let's see what it is. Okay, given 3 ints, return true if 2 or more of them have the same rightmost digit. Okay, and of course the ints are non-negative. All right, so this is easy, right? How do we get the last digit of a number? We do modulo 10. Okay, so 17 modulo 10 is 7. That's the remainder. Somebody asked earlier, hey, what's a good application of modulo? Yeah, here you have one, right? If you want to find the last number or the last, the last x digits in a large number, you can use that. Okay, so how do we check if 2 or more of them have the same rightmost digit? Well, we just do all 3 of them. So if a modulo 10 equals b modulo 10, okay, that's going to be a true, right? 2 or more will have the same thing. Then return true. Else, if b modulo 10 equals c modulo 10, return true, right? Because then we know 2 of them have the same last digit. Else, if a modulo 10 equals c modulo 10, return true, right? If any of those 3 conditions is true, right, then we know that at least 2 of them have the same rightmost digit, and we're good. So let's go. Let's do it. I missed a oh, I got to return the Boolean. Okay. Return false. Okay, so if none of those returns goes through, then I still continue to the end of the method here, and I have to return false. There we go. All good, all correct. Okay. So a simple one there. Just as a point of reference, you could also do it with ands. Right. So one way to check is if they all don't have the same number. Right. I could do it a different way. So let's clear this. So just to show that there's usually more than one way to complete the solution. So if a modulo 10 does not equal b modulo 10 and a modulo 10 does not equal c modulo 10, and one more, and b modulo 10 does not equal c modulo 10, return false. Okay, so if none of them match, then I know that there are no matches. If there are no matches, then there are at least one. So, and then I could do return true at the other end. But Here's a simpler way to do that. I could just do return. Okay, I could just evaluate this in one statement. So if this, right, this is true that they don't match, and this is true that they don't match, and this is true that they don't match, then I know none of them match, and I should return false. Otherwise, if at least one of these is found to be false, then I know there is a match. So let's do this. Something went wrong. Well, if A modulo 10 does not equal B modulo 10, A modulo 10 does not equal C modulo 10. Oh, I think I got to return not. Got to flip it around. Yeah, my bad. So I have to do the opposite of that. So I have to return not all this. Then I get it. Okay, so anyway, the point is you can do it by testing ors, you can do it by if else's, you can do it by one complicated and statement. There's usually multiple ways to approach a problem. There's not one single answer. All right, we'll go do another one, do another logic one. Anybody want to call out a second one? What we got here? Hello?
Caught speeding. The second one caught speeding.
Caught speeding. All right, let's take a peek. Uh-oh, you're driving a little too fast. You get stopped by the cops. Write code to compute the results. So 0 is no ticket, 1 is small ticket, 2 is big ticket. If 60 or less, you get 0, so you're good. Speed is between 61 and 80, so 1. 81 or more, result is true. Unless it's your birthday, on that day your speed can be 5 higher. Okay, so that's interesting. So we could do this in two ways, right? I could do one whole separate branch for the birthday. We could try to implement the birthday into the method itself. So one thing you'll find, in general, you can code for two kinds of optimizations. You can code in a way that's easy to write quickly, or you can code for a way that's going to run more efficiently. And depending on the scale of what you're doing, one may be more important than the other, right? So something like this is going to be a quick little program you slap together. You don't want to spend a lot of time on it. It doesn't have to run perfectly. It's so simple, even if it takes, runs 10 times slower than it needs to, it's going to be good enough. However, you're doing some big, complicated enterprise grade thing. Yeah, maybe you want to take some time, program it well, so it runs more efficiently. But here we're going to do it. We're just going to do it cheap and sloppy. So we'll just break it down like this. If is birthday, okay, and then else. So we have two separate blocks, and then we'll just do the computation separately for each one, right? We'll say if speed is less than or equal to 60, return 0. Okay, no take. Oh, it is the birthday, so return 60 less than 65. Oh man, it's your birthday. You can go fast. Else, if speed is less than or equal to 80, 85, because birthday, return 1. Else, return 2. And we do the same thing down here, just with the base numbers. If speed is less than or equal to 60, return 0. Else, if speed is less than or equal to 80, return 1. Else, return 2. And I hope this works. Let's see what happens. There we go. All good. Okay, questions on either of these? So pretty simple, right? We did some ifs, we did some if else's. Not a whole lot of takeaways today. I will write them up in the chat. Let's see. Yeah. So key stuff we covered, right? Number 1, if else's, we covered that. And we started off with order of operations, including Booleans, logical expressions, logical and comparison expressions. Okay, that's it. Questions on any of this stuff? All right, well, tomorrow, Friday, we'll come back. I got a little bit more of the slides to fill out, this thing called a switch statement. and we have a little bit more practice coding to do. We can start off the day with that, and then, I don't know, we'll see what else we can do. That's all I got for you then, if there are no further questions.